in 98. And they decided to bring me here from overseas. So here I am, 21 years later. We have a group of great speakers today. Thank you everybody for being here. We'll start with a representation from AirLogics, and we'll ask Marc Hudock. Marc will do introduction of his team, but they will talk to us a little bit about a refresher on the basics of PAM in the context of risk management and some new state regulations and guidance for PAM. So Marc, whenever you're ready, take it away.
Thank you, Norbert, and thank you all for joining us. So why are we going to talk about the fundamentals of perimeter air monitoring? You know, you come to a conference, you see a lot of really splashy talks, really in-depth kinds of things. And I think, you know, in perimeter air monitoring, there aren't that many regulations out there. There's not that much guidance. Not many states have very well-defined specific requirements. So you see a patchwork of things going on out there. And some not at all, you know, some don't do it at all. So we felt like it would be good to elevate the practice and get the fundamentals and the basics of perimeter monitoring out there to elevate the game. And, you know, AirLogics is a professional services company. So, you know, we distinguish ourselves from equipment rental companies, although we do rent equipment, but we really want to put some thought into this, and we want to elevate the practice. So that's why we're going to cover the fundamentals. And so today we have with us on stage the AirLogics gang. Bill McClellan is our senior field operations guy. He's been with us for 23, 24 years. He's been at every single AirLogics deployment out there. And, oh yeah, I have this here. Myself, Marc Hudock, Senior Vice President for AirLogics. Bill McClellan, as I mentioned. We have Tyler Rao with us. He's been with us for about 6 years, and as have Kyle Bartsch. So again, I talked about the fundamentals. Here's where we're going to go today. Objectives. Every perimeter monitoring plan needs to have a clear objective. What are you going to do? Why are you doing it? You need to define the constituents of concern. There's a variety of constituents out there. Every site's different. You need to have a good conceptual site model. We'll talk about that very briefly. And it's easy in soil and groundwater. You know, everybody is used to that, but in air, maybe not so much. You got to define those action levels. What happens whenever you exceed a certain level? What equipment do you need to meet those objectives? We'll talk about that. Where are you going to put these monitoring points and at what frequency? You have to define that, be very clear. And what kind of things go into a baseline sampling? How do you define the background before you get going? What kind of O&M do you need to do on that equipment that you specify? Every set of equipment has a different kind of O&M requirements. And then what do you do with that data? What kind of reporting are you going to do? So that's where we're going to go. And I'm going to turn it over to Kyle.
Thank you, Marc. Good afternoon, everyone. I'm Kyle Bartsch with AirLogics, and I'm going to talk to you guys about some objectives for perimeter air monitoring. Can't see over this. So first thing we usually do with the objectives for perimeter air monitoring is make sure we're documenting any potential offsite release of constituents of concern. We do this through data acquisition of either 24-hour, 24/7 data monitoring or 8-hour monitoring, whatever is best for our client at the time. And we do that by acquisitioning that data, holding onto it, and storing it for prolonged use in case of future exposure risk assessments for offsite receptors. So after the life of the project, we're able to provide assurance to the client that they have not exposed anyone offsite. And we're able to do that mostly through the data reflecting our mitigation efforts with the client, as in providing a stop work when an action level is reached or some type of VOC suppressant, either surfactants or foaming.
Yeah, let me just say real quick, that last point, if you want to go back, Kyle, you know, anybody can document data, and of course you can do your risk assessments after the fact, but the real magic happens when you use it to minimize impacts to the offsite receptors. You know, you intervene, you work with the site managers. That third objective is, to me, that's, you know, especially when you use real-time air monitoring techniques, that's where, you know, you really get a lot of good value out of it.
Yeah, and it's very important for you and a client to set up a action plan. So when you know when you're reaching that action level, you are taking pre-agreed upon measures. So the data reflects that later on, and you're covering yourself for future liability. And then on top of that, we use conceptual site models to create an idea of how the contaminants could be moving through the environment, transportation mechanisms, pathways, exposure routes. Are these contaminants that are going to be mostly airborne? Is it going to be dust that settles out that gets on someone's windowsill? They touch it and then they touch their face? Is it going to be ingestion? This is all kind of stuff that we take into consideration when we're setting up perimeter air monitoring. And then that comes down to the constituents of concern. We on our sites typically work with VOCs. We do dust monitoring for semi-volatiles as a segregate and PAHs in general. We typically use benzene as a benchmark for VOCs, since that's the biggest constituent of concern we have. And we'll, depending on the equipment, switch over into specific compound mode and some of our gas chromatographs to get specific speciation for BTEX compounds. And these are some of the action levels used. I believe this is from New Jersey, but it's probably not too far off from the NIAC standards. But it's basically broken up into 4 categories. All are either dust or TVOC, and they're within those categories either non-carcinogenic, as you can see here, or they go on to the carcinogenic levels. And from that, you usually work with a CIH, or we are able to provide a CIH to give you a better idea of what you're working with and what action levels you'd be wanting to have implemented on your site to be keeping yourself as safe as possible. And on the sites that we are on in New Jersey, we typically do a 15-minute average of 150 micrograms of dust for action levels. And TVOC, like I said, we use benzene as a surrogate to base that action level. So a lot of our gas chromatographs that will kick over into a specific mode will go TVOC, get a TVOC reading of 0.5 parts per million, kick over into compound specific, and then measure for any of those chemicals listed down there, from benzene to xylenes to trimethylbenzene. And as I said, we use the NIAC air quality standards for most of what we set things up with. That does come into play on whether you are doing 24-hour monitoring or 8-hour monitoring for a workday. You got to want to consider what's happening on site. Are piles being left there? Is there exposed material? Is there a hole open? Is there anything that could be contributing to constituents migrating off site during non-work hours? And is that something you want to have covered through data monitoring? And
also, I'd want to just throw in there, Kyle, that this is not an OSHA. These are not OSHA standards. This is not an OSHA scenario we're talking about. It's not for workers. We're talking about perimeter monitoring. So, when you're setting up your plan, we've seen those kind of mistakes being made, that people are picking OSHA standards, the action levels based on OSHA, but we're really going after the National Ambient Air Quality Standards.
yeah, because these exposures are based off of people that are living around the community, not just working there for an 8-hour period. So their exposures could be much more longer term if there is a need for it. And I believe that's it for me. And next up will be Bill McClellan to talk about equipment needs.
Thank you, Kyle. Afternoon, everyone. So yeah, we're going to talk about, my name is Bill McClellan, by the way. I've been with AirLogics for, as Marc said, about 23, 24 years. So I'm going to talk a little bit about equipment needs and frequencies and, how you want to manage your sites. Which one is it? Oh, the big guy, okay. Okay, so when picking your equipment, first thing you need to look at is how you're going to power this equipment. Do you have 110 power? You're looking at generators, possibly. Solar is an absolute possibility, along with batteries. You have a battery option or any combination of those. Reaction thresholds, range of detection. What's the client looking for? What do you need to get down to? What exactly is the goal? Detection limits come along with that too. What type of equipment are you looking for to get down to those limits that might be specified by your client? And what are the action levels? And what are you doing with that data? What are your objectives? Your documentation. You got to have rock solid documentation on these projects. Seamless documentation is key. Reducing impacts to receptors. This is your main point of the project in your air monitoring program, is reducing that impact to your receptors around the project. For actionable data, you need good data. So with that, what equipment do you want to use? We have several options. This would be our 110 powered station. This is our AirLogics Classic. This is our legacy system that's been with us for 24 years. So this is speciation type equipment, has a gas chromatograph. So this has our TVOC kickover that gives you that BTEC speciation, or any speciation that you might need. And particulates as well, typically PM10. This is, like I said, 110 powered equipment. So you need to be able to get power to get this type of equipment on your site. So we also have other options. This is our solar light system. Also has TVOC and particulates. And to the right of that, you can see our brand new AQS1 air qual system, much more nimble, solar battery power options.
Batteries have really been coming along lately with a lot of innovations, and lithium batteries are very, give you a lot more options.
Yeah, lithiums have come a long way, half the weight, and you get probably 50% more running time. So confirmatory sampling. So this is a laboratory sampling that we do in conjunction with our air monitoring system. And we do these samples on an 8-hour basis. Some people like to do 24-hour, and these go to the lab for analysis. The analytical report generated, and then we thus compare that when we get the results into our 24/7 data as a comparison. And let's talk about frequency and locations once you pick your equipment. So this is a typical project site. This is in New Jersey. Oop, went the wrong way. So you can see these locations. There are 8 stations around this site. This site is approximately probably about 6 acres in size. So you want to make sure with this that you're looking at your receptors. So we place these strategically on every site. So the only way to do this is to get boots on the ground. You got to get somebody out there to really see what the surrounding community looks like. What are your receptors out there? What, not only are you looking to protect, for instance, you've got this entire residential area right here. You're looking to see what can potentially impact your site from the outside, which is just as important. So you have industrial in certain areas, so you want to make sure that you have a good monitoring coverage on your project. And with that, what are your prevailing winds? This is where you need to really get some historical data, talk to people on the site that have had a little bit of history to find out what that prevailing wind might be. And as I said, what's the size of the site? You want to have enough stations you can really cover this adequately. Receptors, where are your receptors? Like I said, we have high residential in this area and then some residential back in here along with businesses. Which gives you how many stations. And this site, as I said, we have 8 stations around this particular project. And typically these remain in place throughout the entire project. And with our systems, we set these up. A lot of times you'll get people that want to change and rotate stations based on what the winds are. Our systems stay in place, and we base that off of an on-site weather station that tags every sample throughout the entire day, 24/7, with an up-down crosswind indicator. So we know exactly what's going on at every minute. And frequency, how often, once you get this set up, are you going to monitor? So 24-hour versus 8-hour, real time versus spot sampling, doing a little bit of handheld along with that. So this particular site is, I wanted to throw this in. This is probably one of the most challenging sites we ever did. Also in southern New Jersey, this site was 3,000 feet of stream. So basically what happened was there was a remediation about 6 years prior to this stream. Once it was discovered, they had found out that residuals were being stored a half a mile down the road in the woods. So everything was dumped at the head wall, and hence everything went from there. So 3,000 feet of stream, heavily wooded area with a heavy residential presence on the south end. So this particular client opted to go with, so there's the stream impacts. They opted to go with a 24/7 system because of this high residential area. Very very conservative client. And that's immediately to the south, as I mentioned.
Bill, this is the one where you leapfrogged over.
Yeah, so you can see here all the locations. So documentation was key on this site. Make sure we had every location pinned for any exact date. So we surrounded this particular site, the stream, with 6 stations. As the contractor would advance, we would leapfrog stations over to make sure we had optimal coverage. So there was a lot of communication with the contractor every single day. Hence the long stick. So this was key on the project of moving our stations. And there's the classic heavy bulky equipment, but was needed for the speciation that we were looking for in this project. And before you even start that, background sampling, and why do we do it? The interesting part is there's no guidance on background sampling. So we've taken an approach over the years to get a good baseline, to make sure you get a good idea of what your baseline is. What are the impacts coming from on-site, also from outside your site? And you want to do this before you do anything, before you break ground. 1 to 3 days typically is what we use for a background set. And that's it for me. And we'll bring up Tyler Ralph for a little O&M.
How do you click? Just a green button? Yep. How's everyone doing? So we're going to talk about operations management that go along with perimeter air monitoring. So first, let's talk about equipment OEM. So equipment management. What equipment are you using on the perimeter air monitoring and the expendables that go along with it? Are you using a PID, a dust meter, or are you going to use a field GC? If you're using a field GC, you're probably going to be cleaning lamps and changing filters more often than, say, your standard PID. You also want to think about your calibrations and the frequency of those calibrations. What calibration gases are required? Is it 10 ppm, 0.5 ppm? Are you using 1 ppm? Are you doing speciations for specific compounds? So we use on our sites a BTEX compound for benzene and toluene. And then you have to know how often are you doing those calibrations, which could be based on the manufacturers, based on what your client recommends. You could calibrate once a day in the morning. If you have an action level or alarm above your action level, you maybe calibrate again at the end of the day. Or like our new system where we have displayed in the exhibit room, you can calibrate that once a week, which is pretty nice for the labor on site. And then you have your data OEM. So you have your ongoing data visualization and management and reporting. You have your interactions with the clients and your site managers. This is where you're on site, you're communicating your current air data levels and your data summaries. You're attending the weekly site meetings. You're letting them know any reasons of concern where you're getting kind of close to your action levels. And then you have your management of your offsite impacts, which is done in the field. It's done in the field while you're observing, documenting, and reporting. Just like this past summer, we had a site where our dust level readings were kind of skyrocketing way over our action levels. And we went out in the field and couldn't really figure out where the dust level was from. By checking in on a few other sites that we had along the East Coast were all elevated dust, we kind of honed in and realized that the West Coast fires were, increasing the dust levels on the East Coast, which we've never really seen before. Here's an example of just a report, a daily deliverable we'll give to the client. Shows your VOCs, your dust, your TVOC min and max, your wind direction with the wind rows, and your wind speeds, obviously. And then you have your reporting where for your reporting, you obviously want to be very transparent and complete. You want to make sure your reporting is risk-based and that you're also you're at meeting all of your state regulatory requirements. And that's it. I'm going to hand it back to Mark and everyone else for any questions you guys have.
Thanks, Tyler. Thanks, guys. And yeah, that concludes our program. Just a whirlwind tour of the basics of perimeter air monitoring. Anybody have any questions? I know that it's we're between you and happy hour, so
And
recognize.
if you have a question, I'll pass the mic so we can do the recording.
No, I don't think there's any questions. I have a question. What's the longest that you guys have done a background sample for? You're 5 days? Okay. Okay. Have you ever had a client who's, said, hey, you know what, we know there's things going on in the neighborhood and, whether it be activities, industry that said, you know what, we want to make sure we do background sampling during that time when we see that activity to capture it. And then like, do you get involved and say, you know what, they always unload the garbage here on Tuesdays or something and to factor that in? Grills, yeah. Fireplaces, grills. Okay.
I think we typically do it on a Friday over a weekend, just so we get a little bit of a work day.
Take the mic, please.
Yeah.
We typically do confirmatory sampling or background confirmatory sampling on a Thursday, Friday, and then over a weekend, so we get an idea of what it looks like during a workday and on weekends. But I don't know if there's.
That typically works well. Just you want to get a good representation of what it is during workday, like Kyle said, and the weekends, because you can get all kinds of different things that'll happen. So you really want to know before you start, to head off any surprises before it becomes a problem quickly. So it really gives you a lot of information up front.
Okay.
So we've heard a lot of presentations for projects are, I feel like I should whisper now, over a couple years. Do you ever conduct background studies throughout the project at like various seasons?
We have done that at times through different phases. They want to get another background set. I mean, you're kind of outside of the realm of background at that point, but before they start that next phase, maybe it's in a different area of the project. We have done that in the past. Yeah, that's not uncommon. Yep.
Also, when we do confirmatory sampling, we make sure to do an upwind and 2 downwinds so we can see what's coming from off-site and what's coming from the site itself.
Yeah, I think some of our industrial clients, the background sampling is taken a lot more, they discern it a lot more. So if you have an active industrial client, chemical company that makes XYZ, and you're undergoing a remediation there, if you do a background study at an active plant, you have the potential to detect things that they're emitting, that otherwise maybe aren't documented. As opposed to an MGP client, where most of our MGP clients, there is no activity going on. There's the MGP plant is gone. So there might be a parking lot or, some type of this, that, or the other, that the risk of doing a background study is not that great. You're not going to implicate them to, of data that otherwise wasn't known. So it depends on the client. Some clients in the MGP space, background, no problem, do it, whatever you think we need, whatever you think you need. But in the industrial world, it's a lot more discernment is used to figure that out. And then to your question, do you do it in additional times? Well, they really want to be careful when they do it. Sure, we're confident your remediation is not impact. We see what you're doing here and we've got a lot of controls in place, but the plant that's been operating here for 50 years and may not have all those controls in there that the neighborhood would like to see. So, question back here. Just wait, because we got to get the mic, because the online folks.
Thank you. So do you guys collect all of your data and contain it in one database where it can be showcased to multiple clients, or do you have to be a client in order to have access to your database?
We pretty much leave that up to the client. We just present the data to the client, and it's up to them whether they provide it in a public space or they kind of keep it to themselves unless they're acted upon. But usually a lot of our clients do like to post the data to whatever town or whatever area they're working in. A lot of them even post those daily deliverable graphs on the front of the gate every day. So,
are you able to see the difference between before they implemented your model and after, to see if there's any changes over the year, or is that more like privatized for your company? Like for the database. So you've implemented your product, and then let's say you have several companies that have, can you showcase on your website that it has done a difference, or what it actually?
So like us having perimeter air monitoring on one site versus a site that doesn't have perimeter air monitoring?
Yes.
I don't know if we've done a study on that in particularly, but you can definitely see through the course of our air monitoring and in the data, what we do is pretty much present to the client, like your VOCs are getting high. You might be approaching a benzene exceedance. So they'll take VOC suppressant foam and spray that, stop work. And the action levels never really get up to that 1 part per million. So you can actually see in the data graphs of the daily graphs, like, oh, they foamed at 9 o'clock and the levels dropped. They stopped work because dust was getting too high and it dropped back down to 0, and our averages for the day leveled out. But as far as comparing to having perimeter air monitoring on one site versus not, I mean, I'm sure the productivity is a lot higher on one site, but
I think the rubber meets the road when you have that report at the end of the job, and it's a risk assessment, and the risk assessment concludes there's been no impact to the community, and the report also documents all the interventions that have been done along the way as we've detected off-site migrations of things, catch it, tell the site managers, get it taken care of. And, that's the magic. That's the great thing. One of the objectives we said, the third one is to reduce the risk to the offsite folks. I mean, that has to be a part of doesn't have to be, but you do well to have that as one of your objectives, and involve real-time air monitoring, involve intervention, involve site managers and experienced guys that can tell the difference between a garbage truck belching over here and, what's going on site. Okay.
I think it was Tyler who mentioned that if I remember correctly, the wildfires on the West Coast, the fact that your ability to monitor things correctly on the East Coast, is that correct?
Yeah. Mhm.
Wow, that's
Yeah, we picked them up at multiple sites.
Yeah,
And
and just blanketed the entire multiple sites.
And it had a signature. It was a sort of a gradual increase. You could see it, and then it stayed up there, and then it came down a couple of days later. But as opposed to like spikes that you see for the the belching garbage trucks or the barbecues or the
And trucks driving by the
trucks,
station.
yeah.
Or whatever.
well. Mark, Bill, Kyle, Tyler, thank you very much for informative presentation. Our next speaker is Heidi Heiss from Eurofins Air Toxics, and Heidi will talk to us about EPA 325 passive sorbent tubes used to monitor VOCs in former MGP sites and some examples of successful implementation.
Great, thank you. Thanks for the invitation to speak today. Big crowd, I love it. I'd like to present my topic on EPA 325 and using it for monitoring VOCs as opposed to TO15, which is a common approach used for ambient air monitoring, and specifically during remedial action at MGP sites. Now, we need a little interaction here with the crowd. So how many of you have actually heard of EPA 325 in terms of methodology? Okay, good number. And how many have considered utilizing it on their site, their MGP air monitoring, perimeter air monitoring site? All right, well, let's start with a little bit of background here on 325. So EPA 325 describes the sampling and analysis of VOCs in ambient air using passive sorbent tubes. And this method was promulgated in December 2015 and published in the EPA 40 CFR Appendix A. Now, this method was largely written to support what's called the refinery sector rule update, and specifically to address the fence line monitoring rule that's in that refinery sector rule. And what this rule requires is that every single petroleum refinery in the US has to deploy these passive tubes around the fence line. And depending on the size of the refinery, it could be 16 samplers, it could be up to 60 or more samplers. And every 14 days, they're going out and harvesting a sorbent tube and replacing it with another sorbent tube. And they're monitoring benzene. Now, the purpose of this benzene measurement is for the refineries to keep track of and determine how well are they managing fugitive emissions at their site. So they're getting a 14-day average of benzene continuously. And they've started doing this back in early 2018. and they've been collecting samples ever since. So you think about it, there's 140 so refineries in the US, and they've been sampling every 2 weeks since early 2018. So we've collected, the industry's collected thousands and thousands of these EPA 325 samples in support of this rule. Now, when the EPA included this 325 method into the refinery sector rule, they did evaluate a couple technologies, including the TO15 method, the canister method. They also looked at some real-time methodology, real-time GCs, and they selected the passive sampling network and the subsequent EPA 325 method because, one, it was a reliable and cost-effective method. It's also able to generate trace level detection limits. And finally, and importantly, you can use it to generate accurate and precise results. So we talk about this as being a new method, and I really do want to emphasize that this technology has been around probably since the 1980s, and it's been used primarily in Europe. There are ISO methods, there's a European method, as well as now an ASTM standard practice as well. So the sampler is shown here. For 325, it's simply a stainless steel tube. The length of this is about 4 inches long from end to end, and it contains a sorbent bed. On one end, we have a storage cap, and then on the sampling end, the storage cap is removed and is replaced with this diffusion screen cap, which then exposes the sorbent bed to the environment. Now, sampling is really simple. We're actually following Fick's first law of diffusion that describes molecules moving from a high concentration to a low concentration gradient. So that gradient is driving that movement of VOCs. So in the context of the passive sampler, we have the concentration of VOCs in the environment and the concentration of the VOCs right at that surface of the sorbent bed, which is essentially zero. So it's that concentration gradient that's causing that molecule to move from the environment to that sorbent bed. Now, the rate at which those VOCs move through that opening is called the uptake rate. And as long as we keep that concentration of our chemical of interest near zero at that sorbent surface, that uptake rate is constant. So what that means is as that molecule approaches the sorbent bed, it's going to get pulled out of the vapor phase and retained on the sorbent, thus maintaining that zero concentration. So the sampler is set out for a period of time. To stop the sampling, you simply remove that diffusion screen cap at the end and replace it with a storage cap, seals up the sampler, and it gets sent to the laboratory. So once we're in the laboratory, we are going to measure the mass of the chemical of interest on the tube. And we do that using a thermal desorption technique. And the analysis, the finishing technique is GCMS. So mass doesn't really help us understand what the concentration is. We really need to find a way to convert that mass into air units of micrograms per cubic meter. And to do that, we use that uptake rate that I just talked about. So the uptake rate here is shown in units of mils per minute. So it kind of looks like an active flow rate, but in reality, you can think of it more like a diffusive flow rate. Now, one key part of this uptake rate is that it is chemical specific and it's sorbent specific. And those uptake rates are generated through a series of empirical determinations. So the samplers are put in an exposure chamber and they're challenged under a variety of environmental conditions, changes in percent relative humidity, temperatures, concentrations, and durations to generate an uptake rate. And a compound that's well suited to the sorbent should have a relatively consistent uptake rate across that range of environmental conditions. Now, those uptake rates are published in EPA 325, but you can also find them in some of the ISO methods as well as some that have been published in peer-reviewed journal articles. So looking at the uptake rate, we then need to know that the sampling duration, and that's in units of minutes. So basically, when did you start collection and when did you end collection? So we end up with mass on the numerator and a volume on the denominator, do a little unit conversion, and you end up generating a concentration in micrograms per cubic meter. But you can see that sampling duration plays a pretty big role here in the sensitivity of the method. So if we put our reporting limit here, that means that the longer we set out the sampler, the lower our reporting limit in terms of micrograms per cubic meter. And that comes into play as we start using this technology. So if we look at considering using this technology for MGP as compared to TO15, we really need to evaluate a couple key parameters. How do these two methods, TO15 and EPA 325, compare in terms of field implementation? What are the differences? What are the advantages and limitations in terms of the target compound list that can be measured? Next, what is the implication of 325 versus TO15 in terms of reporting limits and sample duration? Like I just mentioned, that sample duration plays into that reporting limit determination. Of course, we need to have reliable data, defensible data. If we're going to be using this data to support a risk assessment at the end of the program, we need to make sure that we're generating data of high quality. So how do the two methods compare in terms of data quality objectives? And then finally, we're going to just quickly go over some method performance considerations where we went out and did some side-by-side comparisons with TO15 and 325 as well. So let's start with the field implementation and look at the differences of 325 and TO15. Now, TO15 has, of course, some things that have to happen in the field. We need to make sure that those evacuated canisters connect securely with our flow controllers. And then we generally have a sampling cane as well. So we need to make sure all of those pieces connect, they're sealed, there's no leaks, and also that the canister has sufficient vacuum. And these are all mechanical pieces of equipment. So as a lab, we prepare and analyze hundreds of TO15 samples. We have a long list of checks before that equipment goes out to make sure there are no leaks, everything's working properly. However, despite those checks in a lab and also in the field, there can still be some issues. We can have a canister that loses vacuum on the way to the field or during the field checks. And so that sampler, that canister is no longer usable for sample collection. And you can also have flow controller failures as well. Now, the flow controller flow rates are set in the laboratory, and they're set such that that ending vacuum at the end of our sampling period, when we're retrieving the sample, say at 24 hours, that ending vacuum is in the range of about 2 inches to 10 inches. So we're targeting 5 inches of vacuum remaining in the canister, but the general range is generally 2 to 10 inches. Now, this is done to make sure that that sample that's collected in the canister is a truly time integrated sample, that you know that you collected that sample over the planned time period. Now, if we end up with a final vacuum of ambient, so essentially 0, or we end up with an exceptionally high vacuum, we're not really sure when that sample collection took place. So in some cases, this will invalidate the sample. We have some projects that if we're running at ambient or if we're running at a high vacuum, they'll actually invalidate the sample. So it has some pretty serious implications in terms of the program. Now, looking at a typical MGP program, say sampling over the course of a year, what we generally will see is vacuum discrepancies on the order of about 2.5% of the samples might end up with a vacuum outside of the desired range. Now, the problem is that this is often clustered, these failures are often clustered around weather extremes, which pretty common in the Midwest and the East Coast, that what we generally see is sampling conditions of very cold temperatures. The canisters will generally fail by ending at a vacuum of ambient. And so we know that those flow controllers and cold temperatures do fill faster than what they're calibrated for. And the lab can adjust for that. But when you're talking about below 0 temperatures, these flow controllers just can't be adjusted to perform reliably time and time again. So these are very extreme weather conditions. So that's where we see a lot of the failures. On the flip side, when you're sampling in high humidity conditions, we tend to see if there are failures, it tends to be on the high vacuum side. So high temperature, high humidity. And we think this could be due to moisture potentially blocking the flow or constraining the flow through the flow controller. So we see a greater percentage of that 2.5 is not spread out equally. It tends to be focused on those periods of extreme weather. So let's see how 325 compares. Well, 325, I just kind of talked through a couple slides ago how to do the sample collection. Again, it's just a matter of removing the storage cap and replacing it with the diffusion screed cap, which is just a push of your finger. And then the sampler will sit in a shelter to commence sampling. So that requires very little training in terms of how to use the equipment, how to do leak checks, and also there are no field checks or calibrations. So in some cases, those flow controllers, not only are the flow rates getting checked at the laboratory, for some programs, the field team is also checking them and making adjustments in the field. So definitely an added task for the field team. So with the passive 325, there's no checks, there's no mechanical equipment, there's no vacuum that can fail. So from a reliability standpoint, they definitely show an advantage as compared to the canisters. And the final bullet point here is that these samplers perform over a range of weather. And if you think about it, those samples that were collected around the refineries that are continuing to be collected, they have gone through Hurricane Harvey, they've been through winters in Wyoming and Alaska, and to date, we have not seen any sorbent tube malfunctions due to weather or any sort of tube malfunction. So the samplers are very resilient. To note though, that there is a temperature effect on the diffusive uptake rate, which makes sense. So the molecules are going to move slower under cold temperatures. And the EPA 325 method takes that into account. So part of the method requires that you have an average temperature over the sampling period. That average temperature is used then to adjust the uptake rate to field conditions. And that equation is in the 325 method and is part of the concentration calculation. So yes, temperature does affect the sampler, but it's something that can be compensated with the equation in the method. So the key takeaway here is that EPA 325 does streamline MGP efforts. It removes the weather factor, which can be pretty significant, and it also eliminates invalid samples due to vacuum issues of the canisters. So let's move on to another practical aspect of field implementation. And again, a picture is worth 1,000 words. So what I have here is one MGP site that we're using our conventional TO15 canisters. This site is using about 6 sampling stations with QC. So of course, we've got 2 big boxes here with the 6 liters. And right next to it, we have another MGP site that we're supporting using 325. And we've got the tubes here that are stored in these little storage files. And we've got 6 sorbent tubes. So you can imagine for a large MGP program where you've got multiple shipments going out, perhaps they're sampling every day or every 3 days, you can have quite a few boxes building up. So just from an ease of use perspective, the takeaway is that the EPA 325 samples are much easier to work with, and it does reduce shipping costs as well. So let's move from the field to the technical side of things. I want to show you how these 2 methods line up in terms of target compounds. So this really depends on your project objectives. Now, TO15, we have a full suite of analytes available. And it really depends on what's in the laboratory's calibration mix. Now, this can vary between labs, but in general, I would say most labs are routinely calibrating for 60 compounds or more. And we can measure compounds kind of in that C3 to naphthalene range, which is about C12. But if we look at 325, there's only a subset of target compounds that are appropriate for 325. And those compounds are generally of a very similar vapor pressure, similar volatility. So we can't tackle this large range of C3 to about C12. We're going to have a smaller subset, and these are going to be pretty close in vapor pressure. So what that means is that we have a more limited list. In addition to that, we need to make sure that we've got uptake rates, because that uptake rate variable is very important in terms of calculating that concentration. Luckily for MGP sites, oftentimes the compounds of concern involve BTEX. And BTEX is very well suited to these passive sorbent tubes. And there are a number of different sorbents that have established uptake rates as well. And we can also add a few other compounds. Styrene often comes up at MGP sites as well. And we do have uptake rates for Carbopac X, which is a graphitized carbon sorbent. And we also get requests to do naphthalene. And this requires a little bit weaker sorbent, and this is Carbopac B. Now, to note, depending on our list, we may need more than one tube. So that would be something to consider when looking at EPA 325. So the takeaway here is that EPA 325 is suited to MGP programs that are limited to a site-specific SOP or a site-specific list of VOCs. So if you're trying to do a full characterization, then the TO15 would be a better suited solution. Let's talk a little bit about reporting limits and duration, sample duration. So for TO15, the typical sampling period is generally 24 hours, but in some programs, it's getting extended to 72 hours, cuts down on the field efforts and the number of canisters. As we move to the 72-hour flow controllers, we start to see an increase in failures because we're working at very low flow rates. And so the incident of failures for those flow controllers about double. So instead of having a general failure of about 2.5% over the course of a year-long program, we may end up with something on the order of 5%. Now, of course, those reporting limits, they don't really matter if we're using a 24-hour flow controller or 72-hour flow controller. Reporting limits for TO15 are the same. And so we can see here on the benzene figure that TO15, the reporting limit for a typical ambient air type platform from a laboratory would get you a reporting limit on the order of 0.5 micrograms per cubic meter. Now, if we look at 325, we can sample in these shorter periods. We can do 1 day and even shorter if we wanted to. But you can see that that reporting limit for benzene is about an order of magnitude higher in this scenario than TO15. But as you increase that sample duration, that reporting limit will decrease proportionally. So by the time you get out to 14 days, you're seeing a reporting limit that's similar to EPA 325. So what does this mean for MGP sampling? Well, this is a typical suite of chemicals that we perform for MGP. And what we see is that most of the MGP work that we're doing for 325 is utilizing either a 3-day or 6-day, and occasionally they may consider a 14-day as well. So if we look at the 3-day, generally we're getting a BTEX reporting limit about 2.5 micrograms per cubic meter or less. And then once we move to 6-day, we're in the range of about 1 microgram per cubic meter, which is a reasonable project action limit for ambient monitoring. So it's really important to understand what your project action limit is to see if this program, this method, EPA 325, is appropriate as compared to TO15. And oftentimes there's a pairing of real-time measurements. These might be measurements during the workday itself, or it could be a 24/7 measurement, but they're routinely paired with a 3 or 6-day EPA time average ambient monitoring. So those are longer durations. So to get an idea of what's happening during the workday in terms of exceedance, and Marc and his team talked about this, the real-time measurements can provide that information. The EPA 325 time integrated samples would give you more information about chronic exposure to the nearby receptor. So more of a risk assessment number over a period of time. Looking at the differences in the analytical method, I'll just go through this table really quickly, but essentially there's very little difference between the QA/QC protocols outlined in TO15 versus the protocols outlined in 325. A couple of things I wanted to point out. One, both systems use GCMS as the technique. We have very similar initial calibration. 325 does require some additional QC checks where they're checking recoveries every 10 samples and at the end of the batch, where TO15 does not have that requirement. And another note here is that 325 actually describes field QC, including a field blank and field duplicate. So that field blank is simply a tube, leaving both storage caps on the end, put into the station next to the sample. And then the field duplicate, of course, are just two tubes in the station, in the same station for field dupe. So this method actually talks about how to deploy these and what the acceptance criteria is. And it gives the laboratory direction on how to qualify the data based on the field QC results. So that's over and above what TO15 described, which really doesn't go into any detail at all about field QC. So the takeaway here is that EPA 325 method, QA/QC, does align with the TO15. Prior to the EPA promulgating 325, there's quite a bit of work performed looking at the performance of EPA 325 as compared to other technologies. There are large studies that were done using EPA 325 and comparing it to real-time GCs around refineries. There's been studies with 325 and TO15 as well at different time durations. But having literature and journal articles, that's great. It's always better to actually have the samples go head to head for the specific application of interest. And so what we wanted to do is look at the actual performance, go head to head with TO15 and 325. And so I wanted to describe a study that we ended up presenting at the Midwest Energy Association meeting in April of 2018. And this presentation was from myself and Gary Flenchy from EDI. And we were pairing TO15. They were actually out there collecting TO15 at 72-hour intervals. So we had our 2 TO15 for the first 3 days and a second one for the second 3 days. And we did it side by side with the EPA 325 tube that we deployed for 6 days. So it allowed us to compare the average concentration of these 2 TO15 samples with the measured 6-day concentration from the EPA 325. And we looked at our BTEX suite and we wanted to look at seasonal effects and we wanted to sample throughout the year. This was an MGP site in the Midwest, so we had plenty of weather to deal with. So once a month, we would pair our 72-hour TO15 with a concurrent 325 sample. In terms of the result observations, we were sampling in the excavation tent as well as the parameters. So we had a lot of different concentrations to look at. And what we found was really good comparability between the two methods. When we were at greater than 5 times the reporting limit, the bias was well within 30%. So we saw good comparability. We did see some outliers. And when we looked at the detail of the samples, what we found was that many of those outliers that we saw, it was probably about a handful of outliers. The majority of them were because of a TO15 media failure. So in the instances where we saw these outliers, the ending vacuum for one or both of those 72-hour TO15 cans was greater than 20 inches. So again, there was a question about whether that sample in the TO15 canister represented that 3-day average. Therefore, it was difficult to compare it with a 6-day measurement from the 325. We also saw that a couple outliers for toluene as well. And in this case, we went out to the field, talked to the field team, and in the situation, actually, again, TO15 was suspect. Higher concentrations, there's suspect. The field observations did not match what we were seeing in the samples. And bottom line is, what we saw was that EPA 325 demonstrated consistent performance at this MGP site across all the sampling periods, despite the weather, and all the stations. So we got very reliable data using that 325 method. So I wanted to leave you with a few key takeaways. First of all, the EPA 325 does offer some significant practical and technical advantages when we're talking about MGP perimeter air monitoring and some of the challenges that are encountered. Now, the sites that have implemented EPA 325 for MGP monitoring, it does require some additional upfront planning to make sure that this method is appropriate for their project objectives. So the questions that need to be answered before selecting this method, first, are the compounds of concern available? Do we have uptake rates for them? And so, as I mentioned, the TO15, if you need to have a full characterization, which some MGP sites do, then a TO15 is the appropriate choice. But for many of the MGP sites, we are able to focus in on, for example, BTEX. And the next question to answer, what are the project action limits? And going hand in hand with that when it comes to 325 is what is the duration required to meet these action limits? And so again, looking at 325, a common duration is a 3-day duration, and that will generate reporting limits on the order of 2.5 micrograms per cubic meter or less as compared to TO15. So does that align with your project objectives in terms of your risk-based screening levels? And in the case of the sites that are using 325, they do benefit from a number of factors. One, it's pretty obvious, the streamlined field efforts. Definitely utilizing these samplers instead of the canisters can provide a significant advantage for the people out in the field, deploying the samples day in and day out. They have reliable performance over a range of conditions, and in the case of vacuum or canister malfunction, using these passive sorbent tubes does eliminate invalid samples due to any issues with the equipment performance. The data quality requirements for 325 do align with TO15. So you're getting the accuracy and precision equal to or perhaps better than TO15 in these situations. And then finally, I wanted to point out that there are field QC requirements in the method, and that's incorporated. So all the programs are using a similar field QC approach, and the laboratory is reporting that on a routine basis as well. And with that, I leave it open to questions.
Is there a major price difference? Is there a major price difference between the two sampling methods?
In terms of the analysis is the same. The equipment is pretty similar. Shipping is much reduced. If you're able to utilize these longer durations, then you can move from a 24-hour to a 3-day, then you've also reduced your cost. So overall, you're going to have a significant cost savings, both in terms of analysis equipment and field efforts as well.
All right, thank you.
Yep.
Question
Yeah.
on the laboratory analysis timeframe. What's
Yes.
the response timeframe right now? Unfortunately, with these pandemic times and the
Yeah.
labor shortages, stuff that we asked for usually was 1 week to 2 weeks. It's now a month, and
Right.
it's certainly impacting several of our clients when community outreach is so important and we need to post things to websites. What
Right.
is that turnaround time
Right,
for
right.
the data?
So for our,
Thank you.
like all the refinery works that we're doing, our standard turnaround time is 5 days. Yeah, and they are very much, in fact, some of the refineries and chemical plants are required to post their results on websites. All the refineries are required to post them. They have a little longer time frame to get those posted, but there are some facilities under consent decrees that actually are required to post them within 2 weeks of pulling that sample from the field, and that leaves very little time to have laboratory delays. So our standard turnaround time for all of our refineries are 5 days. Yeah. Yep.
MGP, right?
It depends on how the project's set up, but whatever the project needs, we can do 5 days, we can do a standard 10-day. Yep, yep.
The 325, is that the name related to the size of the pipe, or you know where the name is coming from?
You know, I think it's just next in the numbering system of the EPA. I don't
Okay.
think it has any meaning beyond that. So, yeah.
Just curious. Any more questions for Heidi? Okay, thank you very much for a
Thank you.
very well put together content. So the monitoring plans are changing as they should with the advances of science and our knowledge. Seems like we are no longer in a single pollutant measurement approach phase, or we haven't really been there for a while. Dr. Deborah Barsotti from Emilcott Associates, she's our concluding speaker for the day, and she will talk to us about new directions in air monitoring systems.
Good afternoon. Can everybody hear me? And welcome. Glad to join you virtually. There's a lot of interesting information in this session, and hopefully we're not going to duplicate with AirLogics, but I certainly like to add something to what AirLogics is talking about and give our experience into what the role of air monitoring is and how it's been changing over a while. I'm a board certified toxicologist. I've been doing this for quite some time and want to share some of our experiences. If I can. So what are the challenges, the changes, the drivers for responsible parties with the community? And sometimes we hear community, perimeter air monitoring, or community air monitoring. It's all the same thing, and the goals, objectives and goals are to be transparent and make sure that the offsite receptors are protected. We've heard a little bit today about the issues that have really changed from the past and what is driving all this as air monitorings are going forward state by state. And that is important because we heard today that there really isn't a strong unified guidance, and it's a hodgepodge, and it varies from state to state. And that's a real dilemma for RPs that are trying to approach this in a technically sound fashion and be responsive to regulators as well as to the stakeholders. I'd like to share a little bit what my experience is with what's driving the change in the community air monitoring programs, and show you some lessons learned with deploying hundreds of programs along the East Coast, many of which are associated with the MGP programs. Well, one thing that really kind of has coincided with community air and air pollution is COVID-19. And EPA concluded that the non-white populations, especially the Black communities, face higher risks from particle pollution. Harvard found that increased rates of COVID in areas where high pollution was found. There was a correlation there. Stanford reports that people of color are more vulnerable to COVID-19. So the really focus of these studies and these findings are found that there is a relationship with long-term exposure to air pollution and being susceptible to COVID-19 and other respiratory infections. And more often, people that live at the community in the fence line adjacent industries are emitting hazardous pollution. So along with that, because we got a lot of environmental people from MGP, there's also a community concern for MGP as well as CCR remedial actions, the excavation, transportation, and landfilling of coal ash or from the MGP waste of increased particle matter or volatile emissions. And that's really put local communities at higher risk in their perspective. And they've really tried to bring that to the attention to regulators. And we're hearing a lot about that. In my home state of New Jersey, we found that the EPA and states are really taking a look at these comparisons of where there might be overburdened communities or environmental equity issues, or where there are strong programs now to be looking at environmental justice. And they're taking the overlaying the remedial sites, the air contaminations, and the cancer incidents for one part, to look at the and start to quantitate where these communities are overburdened, and really put into play and focus regulatory activities, whether it be permitting, compliance issues, and just monitoring out ambient air and reduction in sources of contaminants. A new element that we're finding now is a new tool in the public's toolbox. We see a lot of personal air monitors, and that's an interesting concept. This happens to be from the Bay Area, and we heard about the forest fire issue affecting the East Coast. You know, clearly it was affecting the West Coast, and a lot of individuals have gone to taking personal air monitors for particulate matter, and basically they're crowdsourcing and gathering all this data to get an indication of the localized micro environments where there are data quality issues, air quality issues. Some of the regulators, although they embrace this kind of information, they're concerned because of the quality of the data from the personal air monitors and interpretations of that. And they much rather have their more long-term established air monitoring programs. But the problem is they reach a bigger macro environment rather than looking down at the street level in a community, which is the advantage of these personal air monitors. So I think we'll be seeing a lot more of those as well. So let's take a step back from the COVID-19 and looking at what triggers normally, and if we can call what normal is, what triggers the need for community air monitoring. And people in the audience certainly know the EPA RCRA and circular remedial actions. There's also specific programs like New York's brownfields, demolition, where there's demolition activity. There's the stationary sources. We heard today about petroleum industry, refineries, where there's either a mandatory monitoring need or compliance issues where stationary sources are certainly have requirements. Kind of new emerging, and we'll hear a lot more about this, I believe, is the environmental justice, where certain communities are actually being focused, and their resources are looking at reduction in sources, and so that they can reduce those ambient levels of constituent where they're thinking is affecting their health, risk-based areas, and making a marked reduction in their risks to their communities. And then generally sometimes there's just stakeholders' interest that drives that, where there's just more interest, and it can be the stakeholders, certainly can be the RP that really is interested in making sure that they have the good sound data, as others have talked about today, where we can demonstrate at the end of the project or during the project is desirable, that there is no unnecessary exposures to the perimeter or the residential community. Well, we heard earlier, is certainly, there isn't a really good plan, but I can tell you New Jersey DEP will be coming out with a fairly robust guidance on perimeter air monitoring. I was hoping it would be earlier, but it looks like it's more like going to be next spring, 2022, where there is a pretty robust and good, strong air monitoring program that's going to be a requirement for New Jersey, and I think will be used as a model for other states and agencies that are looking for some strong guidance in how to develop a technically sound perimeter air monitoring or an air monitoring program. But the general steps, and we heard this before, won't go over it much, is develop your site exposure model. That's like we're always used to looking at conceptual exposure models, but this is obviously from airborne, so we have to make sure we understand, what our constituents are, the emissions. We need to ascertain which COCs. By the time you're in a remedial action, you already know what your COCs are, but that's from a remedial standpoint. And just to make sure, you got to focus on the inhalation pathway, and you can use your soil data to help you ascertain those COCs. One of the big changes that, and I heard this earlier, is a difference as no longer is our OSHA standards that should be used. And I'm going to use the word EPA type of risk assessment. It is different. Their exposure assumptions, toxicity criteria are all different, but this is what's being now used to establish your health-based toxicity criteria, which leads to your action levels, which we've heard about, that are important, that you don't exceed your health-based criteria, that you stop and mitigate at an action at a higher level before, to make sure you will not get to that lower health-based criteria. And then certainly what's been discussed before is your importance of your monitoring strategy, your methods, and your technologies, but also to pinpoint where you're putting those stations. We heard about the importance of where receptors are, and certainly your schedule. I can't emphasize more the importance of really trying to have a real-time monitoring, and regulators as well, the stakeholders, under the importance of a real-time monitoring, that you can get the answer right away, that you can take an action right away. But the challenge, unfortunately, that the real-time monitoring solutions may not be able to meet those low toxicity health-based criteria that I mentioned, that EPA is going to want you to be able to look at. So the challenge then is to be able to work with our folks in the laboratories, to be able to find a method that can be a real time. And if you can't do that, then you can use the monitoring circuits that we heard about, like particulate matter or dust or total VOCs, remembering that that's going to require fixed lab confirmation for those COCs, that your assumptions that those surrogates are protective have to be demonstrated. So as you can imagine, air monitoring requirements are much more complex nowadays, and really require thinking and planning before your project starts. And as brought up a couple of times is, quality data is an essential, and quality assurance is always a challenge. And while Emilcott certainly has air monitoring services, we can do seamless reporting to the client to meet expectations and be able to provide the 24/7, the data, and the data then the client, it owns that data. It can be uploaded into what we're seeing a lot more now, or websites that, as we heard earlier, require, posting of daily samples and any interpretations. And, those reports are certainly available. Taking that step back to the development of a conceptual motor, we're not going to take a long time on this. I think most people understand what we need to do, but I just want to emphasize the off-site receptors. It is not, and it's on inhalation. Inhalation will be the driver, not dermal, not oral routes of exposures. And the need is to be able to address the full toxicity of a chemical, whether it's a carcinogenic endpoint or a non-carcinogenic endpoint, and realize some chemicals can be transported as both. And from the MGP standpoint, I think we probably all have had the experiences with naphthalene. It's a very important chemical. It's analyzed and considered both as a volatile and a particulate. And those are important. The regulatory agencies wants to see both of these. And I can add to that now with a site in New Jersey, that it's not just a particulate, a naphthalene looking as a carcinogen and a non-carcinogen, it's also as an odor and a quality of life issue. So naphthalene has really become an important chemical in this conceptual model. And it's not just as a toxicity, but also as an odor and quality of life issue. CSM is a cornerstone, and it needs to be continually updated. And so it's really a communicative tool between the RP and the stakeholders, and including obviously the regulators. Let's spend just a few minutes on those health-based criteria. The idea is to be able to establish these in my practice at the front end of the project. So we address the chemicals of concern, understand how low we must go in the analytical methods to be able to demonstrate the protectiveness of human health to the stakeholders, a key issue. And these are health-based inhalation toxicity criteria. They're basically EPA accepted, established, and they're not OSHA. I cannot emphasize not OSHA. OSHA is for on-site worker right to know, are very important criteria, but they are not for those community, living in the community. And I'm going to call this, for the purpose of this discussion, we're going to call this EPA type of risk assessment versus OSHA. It's also should realize that you can make these sites specific, but this is all up to the state. They usually require a screening level, and that can be a cancer risk of 1 in 10 to the -6 or 1 in 10 to the -5th, or hazard quotient of 1 or 0.1. So got to pay attention to that, but those can be used and manipulated given work with the regulators. Recognize that there are orders of magnitude different from the OSHA pill. So that's why OSHA, while important for those on-site workers, is not going to do service for those off-site community receptors. And I can't tell you, you're speaking of your off-site receptors, and the importance of understanding what they are is how many times I go and find that there's a daycare right across the street, or some sensitive receptors. So it's imperative to pay attention to where your receptors are and make sure that your program is monitoring to be protective, but also that your toxicity criteria are taking into account those most susceptible. So as we've said before, the technical challenges of these monitoring and analytical methods are challenging to get down that low often to make sure that you can verify that. And there's also the ongoing issue where often both particulate and volatile analysis have to be are required, and that's certainly what we're finding with naphthalene. So what are the health-based toxicity EPA type criteria? Well, some states you can find those on their webpage. They might list them. Some programs have risk tools, which actually include risk-based calculators that you can basically go ahead and plug in your site-specific duration of exposure, et cetera, and calculate your own. Or you can go to the EPA RSL tables. If you're not familiar with those, just Google EPA RSLs and look up the generic tables and look for the residential air, and you'll see something that looks like what I have on the bottom here. And there are two values that are important. One is the IUR, which is the inhalation unit risk factor, and that's the cancer toxicity factor, which is used for projects greater than 1 year. That's the general standard operating procedure, if you would, that if your COC is a carcinogen and your remedial action is going to go longer, 1 year, you have to evaluate the long-term chronic risk for carcinogens. Much more frequently, you aren't going to be going that long. So shorter term projects, less than a year, you use the reference concentration or RFC, and those are provided directly. And these then can be manipulated or extrapolated to different time frame that is project specific. So again, health-based criteria. These are the health-based criteria that you will directly compare to your laboratory confirmatory results that you will be able to provide to the regulator to indicate that you are being protective of these health-based criteria in your samples. Ideally, you would be able to have real-time monitoring that could do that, but if not, you have if you have laboratory results and confirmatory action, that would be what is needed there. So those are the health-based criteria. This is the important that you have to show compliance with, to show that your project duration, whatever that may be, carcinogenic, non-carcinogenic COCs, that you're being protective of the public. And for your action levels, you don't want to be tagged with those health-based criteria and try to be always protective of those. You want to make sure you're protective before you reach those levels. So action levels I heard AirLogics talk about that are important surrogates, real-time monitoring, where you can make on the site changes and adjustments. So your action levels then help you prevent yourself and the project over the long term exceeding your health-based criteria. And the way those can be used, and I heard this earlier, is that for particulates, you can use the soil concentration to figure that out, and use health-based criteria to develop, to extrapolate to those. And for volatiles, use that health-based criteria and the percent total volatiles to come up with either a PM10, for example, particulate criteria, or a total VOCs, as we heard described earlier. We have to go back to the importance of offsite perimeter community versus on-site health and safety monitoring. I want to give you an example of that and why it's so important. And as I show here is our receptor is our residential receptor. That's the most sensitive receptor. That's what EPA and states are going to require. I chose arsenic because it's always a problem because of background conditions and the importance, again, talks about the importance of why background knowledge, that whether that be ambient air, is very important. So you can see that how low these are, these criteria are. And for the resident, just the average worker, the EPA, these are very low. But look at the OSHA criteria, orders of magnitude for the PEL at 10. And so it just shows why our sensitivity is and why we want to caution anybody from using OSHA criteria when you're talking about the offsite perimeter and community. It's certainly appropriate for on-site health and safety monitoring for those involved in remedial action. But if we're talking about the EPA type of risk assessment for offsite perimeter community, it is not. They're order of magnitude different. I also want to just alert folks that we're not just talking about these toxicity criterias and the need to address things like dust, which is as pointed out, an ambient air quality criteria. It's one of the few established ones that has to be evaluated. But odors have been coming into an issue as a quality of life. New Jersey, in fact, is actually regulating it. So others are as well. And it turns out to be an important issue for actually emerging now with cannabis growing facilities, strong odors, because we're not dealing with toxicity issues. The odor thresholds are very low. And people are complaining about those. So just to recognize that odors has emerged. And dust, as mentioned earlier, is one of the few actual standards for air quality. And monitoring, usually for remedial actions, the PM10 fraction, there is some requirements for PM 2.5, which is actually more of a combustion source, but for normal remedial actions like MGB, it's usually the PM10 fraction, which is 150 microgram per cubic meter for a 24-hour time-weighted average. And at least in New Jersey, you can make no adjustment of that 24-hour. If you're only, let's say, doing your excavation for 8 hours, you can't adjust that. You must basically abide by the 150 micrograms per cubic meter criteria. In drawing to a close, one of the things I really think has been emphasized earlier, but importance of transparency and community relations. Keeping those conversations going, involvement with the community is key. And be able to make sure you have all your tools to be able to enhance dust control. Dust is something the community reacts to, as well as now, as I mentioned earlier, odors. So make sure you have dust control and a mechanism if you have an odor producer like a naphthalene to be able to also be able to assess and control that. And make sure that you recognize that on-site is OSHA, off-site is EPA, and that OSHA isn't going to be adequate to demonstrate protectiveness of human health and the environment off-site. Get good data and be transparent with those monitor results and data interpretation, and document, things like forest fires or that diesel idling near one of your monitors to be able to understand and the data. I've found it very useful to provide frequently asked questions the answers to those as a fact sheet. It's to be able to hand out and address those stakeholders' questions. And then if necessary, hold public awareness meetings and communications. And as we've heard today, one of the ongoing communication tools has been posting of monitoring results and data on project websites, which is growing to be a very important source. But the data must be sound, you must be transparent, and provide documentation of those events that make the data look a little odd. Be very transparent about those forest fires or that trash truck idling near one of your monitors. With that, I'd like to end my presentation, and if there's any questions, be happy to answer. But would like to, I'm sure people are ready for going off for other things for the evening.
Thank you very much, Dr. Barsotti. We are just a little bit over time, but maybe we have time for one question. Anyone wants to ask a question? Okay, again, thank you very much for the presentation. We wish you could be here with us in person, but nevertheless, we understand and we appreciate your time. Thank you very much to all the speakers. It's a few minutes past 5 p.m., so I would say party time. Thank you, guys.